Let's draw the lowest structure for thionyl chloride. Start by counting up the total number of valence electrons. Sulfur comes in with 6. Oxygen, also in group 16, has 6. Chlorine in group 17 has 7. And there's 2 of them. 14 plus the 12 gives us a total of 26 valence electrons to build this lowest structure. Sulfur is the least electronegative of the 3. So we'll put sulfur in the center. And let's put oxygen on one side and chlorines on, let's just spread them out. And the next step is to connect the terminal atoms to the central atom with a bonding pair. Each bonding pair is 2 electrons in a shared bonding, covalent bond, so that's going to use up 6, and we're down to 20 valence electrons. And let's get the octet going on the terminals. Each of them can use 6 more electrons, and we are down with 2. Let's put them on the central sulfur. And so we have the octet on all of them. Check the formal charge on this, and you should be familiar with now that the oxygen generally likes 2 bonds. And let's move a lone pair over there and give that a double bond, because if you check the formal charge, oxygen has a -1 formal charge. So let's do that. Actually, move that guy. Move this guy instead. Make it a little bit more spaced out. Alright, now if we check the formal charges, oxygen got a formal charge of 0. The chlorines have a formal charge of 0, because they have 7 valence electrons in the neutral, minus the 6 electrons they have in the lone pairs, and then the 1 from each shared with the sulfur. Now the formal charge on sulfur is 6 on a neutral sulfur, minus the 2 electrons out here in the lone, and then if you divide the portion it's sharing with the terminals is another 4, so that's a formal charge of 0. So they all have a formal charge of 0, so this is the preferred or stable structure. Now we can draw this a little bit more accurately, so we can might as well get to the geometry, right? So around the sulfur there is 1, 2, 3, 4 regions of electron density. Now this double bond counts as 1 effective pair because they can't separate from each other. So when you have 4 regions of electron density, the parent geometry is tetrahedral, but when you have 1 lone pair, then you get the molecular geometry of trigonal pyramidal or trigonal pyramidal. So let's do that. Sulfur there, we got the lone pair up here, and we can put the oxygen on one side there, and let's get the one of the chlorines out here, and then another one kind of back there somewhere. And so the bond angles here, I don't know what the bond angles are, but this is there's your here's your triangular base. Let me start with that, and then they all kind of like go up there. There's your triangle base pyramid. So we call this trigonal pyramidal or pyramidal. All right, and then the bond angles are probably close to, this one's going to be tough. You got that lone pair repulsion, you got the double bond repulsion, so this is probably closer to 100, and then this one might be, this one's going to be less than 109, but all approximately 109, you can say, less than 109. Let's go with that. And this one's a little bit more less than 109 degrees. All right. If you just know that it's less than 109, that is good enough for me.